Here comes the 16th question. Using age and productivity data from question 4. First part is normalize both attributes using z-score normalization. Formula for z-square is sigma into x minus nu, where nu is simple mean, sigma is sample deviation. Now compute means and sample deviations where age mean nu equals 41.63. Age sample standard deviation is 11.225. Productivity mean is 81.33. Productivity sample standard deviations are 7.1784. Second part is compute Pearson's correlation coefficient and covariance comment on where the relationship is positive or negative. This is the formula. While computed the result, we get coefficient equals to 56.1882 and Pearson's correlation coefficient R. When computed, we get solution that is 0.6973. Covariance is positive and reasonably large. As age increases, productivity tends to increase. Moving on to next question. Suppose student project evaluation scores are given here. First parties equal frequency partitioning. For 12th observations and 3 bins, each bin gets 4 values. First bin is 5, 10, 11, 13. Second bin is 15, 35, 50, 55. Third bin is 72, 92, 04, and 215. Equal frequency ensures each bin has same count, good for balancing representation, but beans can have different width ranges. Second part is equal width partitioning. Range equals to maximum minus minimum, that is 210. For 3 bins, width equals to 210 divided by 3, that is 70. The first bin is from ranging 5 to 75. Second bin is 75 to 145. We have one value. Third bin is 145 to 215, that is we have two values. Equal width keeps the numeric ranges equal but may produce highly imbalanced counts when data are clustered or contain outliers. Third part is clustering, where k means k equals 3. Partition points into three clusters based on numeric proximity. Here, the cluster 1 is low centered, where 5, 10, 11, 13, 15, and 35 are included. Cluster 2 is mid center, that is 50, 55, 72, and 92 are included. Cluster 3 is high centered, that is 204 and 215 are included. Clustering finds natural groupings that reflect data density and separates two larger outliers into their own top cluster. This is often preferable when there are natural gaps in the data. The next question is use a flowchart to summarize attribute selection techniques for feedback analysis. First one is forward selection. Start with an empty model that has no attributes. For each attribute not yet in a model, evaluate model performance when the attribute is added. Select the attribute that gives the best improvement and add it to the model. Repeat steps 2 3 until the adding any remaining attribute does not improve performance beyond a threshold. Last is output selected attribute is subset. Second is backward elimination. Start with the full model containing all attributes. For each attribute currently in the model, evaluate performance when that attribute is removed. Remove the attribute whose removal least reduces performance. Output is final subset. Third is hybrid method. Start with empty set or a small set. Alternate forward addition and backward elimination. After adding an attribute, consider removing any previously added attribute if no longer helps. Continue until no additions removals improve performance.